Risk velocity. AI code security hits the compounding phase. Chris Wysopal, co-founder of Veracode and one of the original L0 Feet Heavy Industries crew, published an unusually candid assessment of where AI-generated code is dragging application security. His core thesis: AI is not breaking application security. It is exposing the fact that the old model never scaled. When a team can produce 10 times more code, but its ability to review, test, and threat model stays flat, they're not moving faster. They're manufacturing security debt. Wysopal introduces the concept of risk velocity, the rate at which new risk is created versus eliminated, and argues it is now the defining metric for CCOs, not vulnerability count. The failure modes he catalogs are familiar but sharpened: insecure reproduction of training data patterns, SQL injection, XSS, SSRF; missing authorization context that LLMs cannot infer from prompts; a comprehension gap where developers accept working code they do not fully understand; and hallucinated dependencies that open typo-squatting vectors. His most provocative claim: secure by design is not a principle. It is an engineering platform decision, and when enterprises treat it as a campaign, it fades. That comprehension gap is playing out in real time on developer forums. A thread on r/c/hatgptcoding crystallized the problem. Generated code appears professional and well-structured, which creates false confidence. The poster's framing is precise. People assume it is correct because it looks correct, without verifying logic or testing edge cases. The proposed solution treat output as a starting point, requiring thorough review is correct in theory and ignored in practice, because the whole point of AI coding is speed. One concrete response to the sandboxing side of this problem: Greywall, a deny-by-default command sandbox that wraps AI coding agents in file system and network isolation. It ships built-in profiles for Claude, Codex, Cursor, Aider, and a dozen other agents. On first run, it shows what the profile allows and lets you approve, edit, or skip. The interesting architectural choice: all network traffic routes through Grey Proxy, a companion transparent proxy with a live allow/deny dashboard, so you can see exactly what your agent is phoning home to. On Linux, it uses bubble wrap plus network namespaces for full isolation. On macOS, Apple's seatbelt sandbox exec. Learning mode traces file system access via strace and auto-generates config profiles for future runs. It is a fork of Tusk AI's Fence project, inspired by Anthropic's Sandbox runtime. Making software agent native, CLI-Anything, and the gateway wars. The question of how agents actually interact with the world's existing software keeps generating increasingly ambitious answers. CLI-Anything, from HKU's data science group, takes perhaps the most sweeping approach: a Claude Code plugin that auto-generates complete CLI harnesses for any software with a code base, using a 7-phase pipeline: analyze, design, implement, plan tests, write tests, document, publish. Point it at GIMP, Blender, LibreOffice, or Audacity, and it produces a pip-installable CLI with JSON output mode, undo/redo, REPL interface, and a skill.md file that agents can auto-discover. The claim: 1,720 tests, passing across 14 applications at 100% pass rate. The vision is that CLI is the universal agent interface: structured, composable, self-describing via .help, and deterministic. In contrast to the fragility of GUI automation or the limitations of purpose-built APIs, a new CLI Hub registry lets contributors share harnesses across the community. On the gateway side, GoClaw takes a different approach to agent infrastructure: a single about 25 MB Go binary that orchestrates multi-agent teams across 13 plus LLM providers with full multi-tenant PostgreSQL isolation. It is a Go port of OpenClaw with added agent teams, shared task boards, inter-agent delegation, a 5-layer security stack, rate limiting, prompt injection detection, SSRF protection, shell deny patterns, AES2, 5, 6, GCM encryption, and MCP protocol support via stio/SSE/streamable HTTP. The resource comparison is telling. OpenClaw needs a $599 Mac Mini and 1 GB RAM. GoClaw runs on a $5 VPS with about 35 MB idle. 7 messaging channels: Telegram, Discord, Slack, Zalo, Faishu, WhatsApp make it a practical multi-channel deployment target. The browser automation angle keeps evolving too. A breakdown of using Playwright CLI with Claude Code for browser swarms makes the case that the CLI approach is infinitely better than the Playwright MCP or Claude in Chrome for parallel execution. You can spin up multiple subagents, each running headless browser automations from the terminal, with dramatically lower token consumption than screenshot-based approaches. The subagent era arrives: cheaper models, Deeper arms. The convergence of cheaper small models and sub-agent architecture is producing a phase change in how coding workflows actually run. A detailed walkthrough of the emerging pattern makes the economics clear. Claude Haiku 4.5 at $1/$5 per million tokens was already enabling sub-agent research at scale, but GPT 5.4 Nano, a fifth of the price, 188 tokens per second, and benchmarking above Haiku on LiveBench, makes the budget essentially unlimited for context-gathering sub-agents. The key insight is architectural, not just economic. Sub-agents handle the token-heavy work codebase analysis, web research, code review that would pollute the main agent's context window, returning only concise summaries. One session spawned 3 parallel sub-agents consuming 70K2M and 1.5M tokens respectively. Completely unreasonable with frontier models, perfectly viable with cheap ones. The critical warning. Sub-agents work for research and planning, not implementation. Parallel implementation agents that cannot see each other's file changes produce hallucinations and conflicts. Every major coding agent, Claude Code, Codex, Gemini CLI, GitHub Copilot Cursor, OpenCode, is now building native sub-agent support. Agents meet organizational reality. Translation, debt, and data science benchmarks. An editorial from Unhyped AI delivers the sharpest organizational critique of agent deployment yet published. The core argument, agent deployment, is a misleading phrase because it makes the work sound like an installation. In practice, delegating behavior to software changes how work moves, how decisions get made, where judgment lives, and who absorbs consequences when the workflow breaks. The author coins AI translation debt, the unpriced work required to make fragmented organizations function as one system. For years, humans absorbed this debt by carrying context, making judgment calls, and repairing meaning at handoff boundaries. Agents do not remove translation debt, they collect it, amplify it, and present it back as review. The result, local throughput rises, downstream confidence does not. Senior staff become the checksum for a workflow moving too quickly to be socially held together. The prescription connects to team topologies. Conway's law still holds, and whatever your organization cannot coordinate cleanly, your agents will not coordinate cleanly either. Designing for humans is now the fastest route to scalable autonomy in machines. Not as a moral stance, but as an operating stance. The flip side. Agents that actually work when the organizational scaffolding is right. Shows up in NVIDIA's KGMon Data Explorer, which claimed first place on the DABStep benchmark data agent benchmark for multi-step reasoning with a 30x speedup over the Claude Code baseline. The architecture splits into 3 phases. A learning loop where a heavyweight model Opus 4.5/6 tackles representative tasks against ground truth and distills solutions into a reusable helper.p. Y library. A fast inference phase where a lightweight model Haiku 4.5 solves unseen tasks using only those pre-built tools in a single pass. And an offline reflection phase where a heavyweight reviewer audits outputs for consistency. The results are striking: 20 seconds per task versus 10 minutes for the from-scratch baseline, and 89.95 on hard tasks versus 66.93 for Claude Code, with Opus doing everything cold. The core insight: that investing upfront in code abstraction lets smaller models outperform larger ones on complex multi-step problems, is a practical validation of the sub-agent economics discussed above. Research frontiers, synthetic data, safe alignment, and neural nets that write their own rules. NVIDIA's Code Concepts dataset offers a clean demonstration of concept-driven synthetic data generation at scale. The team built a taxonomy of thousands of programming concepts, organized hierarchically, identified 91 core concepts relevant to human evil, then generated approximately 15 million synthetic Python problems guided by combinations of those concepts. Each problem was validated via Python's compile function. Including 10 billion tokens of this data in the final 100 billion tokens of Nemotron Nano per training yielded a 6-point improvement on Human Evil 73 to 79, with most other benchmarks unchanged. The workflow is released under CCBY 4.0, positioning it as a reusable methodology rather than a one-off artifact. The taxonomy encodes what to generate. Concept combinations control difficulty and diversity, and the whole pipeline can target domains beyond code. On the alignment front, researchers from Ohio State and University of Kentucky propose an optimistic primal dual OPD algorithm for safe RLHF that addresses a genuine practical gap. Standard primal dual methods for constrained alignment only guarantee average iterate convergence, but the deployed model is always the last iterate. Their framework unifies safe RLHF, one-shot and multi-shot alignment methods under a single Lagrangian relaxation lens, then adds predictive updates for both policy and dual variables that stabilize the oscillatory dynamics inherent to multi-objective alignment. The theoretical contribution is a provable last-iterate convergence guarantee. In distributional policy space exactly, and in parameterized policy space to a neighborhood whose gap is characterized by estimation error and parameterization bias. For practitioners, the implication is that balancing helpfulness against safety constraints need not produce the training instability that has plagued constrained RLHF in practice. A neurosymbolic experiment on fraud detection takes the opposite approach to interpretability. Instead of having humans write rules that a system follows, a neural network learns to extract its own FT, H, E, N rules from its predictions. A standard MLP handles fraud classification while a parallel differentiable rule module learns to approximate it, trained with consistency loss and temperature annealing that turns soft thresholds into readable rules. On the Kaggle credit card dataset, it rediscovered V14, a known strong fraud signal without feature guidance, producing rules like IF V14 plus 0.5 sigma, fraud, with about 99% fidelity to the neural network. The honest caveat: only 2 of 5 runs produced clean rules, as strong sparsity constraints can collapse the rule path entirely. Whether this approach scales beyond credit card fraud to real compliance settings, where rule auditability is a regulatory requirement, not a nice-to-have, remains open. Local AI gets a control panel. Unsloth Studio, voice stacks, and creative experiments. Unsloth Studio launched in beta as an open-source, no-code web UI that unifies training, inference, and export for local models. The pitch: load any GGUF or safe tensor model, train 500-plus architectures 2x faster with 70% less VRAM, no accuracy loss, run text/vision/TTS/audio/embedding models, and export to GGUF, safe tensors, or 16-bit for use with llama.cp, PVLLM, Llama, or LM Studio. The data pipeline is notable. Upload PDFs, CSVs, JSON, or DOCX files, and a GraphNode workflow powered by NVIDIA NeMo transforms them into training-ready datasets. A model arena feature lets you battle a base model against your fine-tuned side-by-side. It runs 100% offline with token-based local auth. The dual-license Apache 2.0 for core, AGP L3.0 for Studio UI is the funding mechanism. Current gaps: Mac training requires MLX coming soon, and first install takes 5-10 minutes while llama.cp compiles. A practitioner's journey building a locally hosted voice assistant for Home Assistant documents the current state-of-the-art for private, on-device voice control. The kind of system where latency, wake word reliability, and offline capability matter more than benchmark scores. On the creative side, a developer built an open-source pipeline that revoices videos using Llama for translation via Translatagema and Qwen3 TTS for speech synthesis with voice cloning. The 3-stage prompt chain clean transcript, translate, adapt for natural speech is straightforward, but the practical lessons are useful. Large models 27B are too slow for TTS pipelines. Batch sizes that are too large cause mid-generation hallucinations, and sometimes reloading the model beats long inference runs. The original motivation: localizing a Fireship video into Russian. Evolved from 19,784 World of Warcraft quest voiceovers built 2 years earlier. An AI debate arena project takes a different angle on local model utility. Instead of one-shot answers, 2 to 6 Llama-hosted models debate a topic in structured rounds, opening arguments, technical deep dives, crossfire, rebuttals, closing statements, with a randomly chosen participant model serving as judge. The motivation is sound. It is genuinely hard to tell whether a single model considered serious counterarguments, though the value depends heavily on whether the debating models actually have different knowledge versus producing confident variations on the same training data. Meanwhile, someone taught Claude to paint using P5. Dot brush, generating stroke-by-stroke canvas compositions. Sky first, then trees, then details that come alive with animated rain, butterflies, and breathing cats. It is a skill file, not a product, but it is a charming demonstration of what structured creative prompting can produce. Open weight model drops. MIMO V2 Pro, Mistral 119B, and Liquid AI. Hunter Alpha, a stealth model that appeared on Benchmarks March 18th, was revealed as an early testing version of MIMO V2 Pro, Xiaomi's next-generation reasoning model. The original MIMO 7B already demonstrated that small models with reasoning-focused RL training could match 32B counterparts. The poster reports V2 Pro was 10x better than Minimax 2.5 inches for their OpenClaw use case, with an open weight variant planned once the model stabilizes. Mistral dropped Mistral Small 4.119B, continuing the MOE pattern where large total parameter counts hide modest per-token active compute, the architectural approach that has become the default efficiency strategy for open weight labs trying to compete with frontier closed models. Liquid AI's LFM2 24BA2B rounds out the week's releases as a sparse MOE designed to concentrate capacity without inflating per token cost, targeting edge and local deployment where inference latency and energy matter more than peak benchmark scores. Infrastructure under the models, memory crunches, allocators, and GPU plumbing. SK Hynix's chairman warned that the memory chip crunch will persist until 2030, a timeline that extends the supply pressure well beyond most industry forecasts. HBM capacity constrains AI scaling at the data center tier, and the downstream price pressure on conventional DRAM and GDDR hits everyone building local inference rigs too. Meta published a mea culpa on gmalloc, the high-performance memory allocator that has been a foundational component of their infrastructure stack, the admission. In recent years, there has been a gradual shift away from the core engineering principles that have long guided gmalloc's development. While some decisions delivered immediate benefits, the resulting technical debt eventually slowed progress. After conversations with the community and the project's original founder, the canonical repository has been unarchived. The roadmap focuses on cleaning up technical debt, improving the huge page allocator for better transparent huge page utilization, optimizing packing/caching/purging for memory efficiency, and ensuring good out-of-the-box ARM64 performance. The subtext, even Meta, with essentially unlimited engineering resources, can accumulate technical debt and foundational infrastructure when short-term optimization overrides principled engineering. At the GPU communication layer, a VLLM user discovered that the widely circulated NCCL P2P disable =0 advice for multi-GPU setups was wrong, or at least incomplete. VLLM relies on NCCL, which assumes NVLink for peer-to-peer communication. Without an NVLink bridge, it hangs. The fix: NCCL P2P LEL =SYS combined with VLLM skip P2P check =1, which tells NCCL that crossing NUMA nodes via the SMP interconnect QPI/UPI is acceptable. The hierarchy of P2P levels: LOC disabled, NVL NVLink only, pick same PCIe switch, PXB multiple PCIe hops, PHB same NUMA node, SYS cross NUMA, is documented in the NCCL user guide but apparently not widely known among hobbyist multi-GPU builders. One caveat: Sapphire Rapids PCIe P2P is limited to Gen 4 due to NTB limitations.